Hello geometry students, here's a video for example 2 for geometry topic 4, lesson 4. It's officially stating the ASA congruence criterion. If you have two angles of one triangle and the included side, meaning the side in between the two, are congruent to two angles and the included side of another triangle, then the two triangles are congruent. Talked about this in the last video. Let's see what they have for practice for us. They have the proof of the ASA, okay? And it's a 2-minute video. Sure, why not?
Given two triangles with two pairs of angles congruent and the included sides congruent, prove that the triangles are congruent. From the information in the problem statement, we can write a formal proof statement. Given angle LMN is congruent to angle RST, angle LNM is congruent to angle RTS, and segment MN is congruent to segment ST. Prove triangle MLN is congruent to triangle SRT. First, translate triangle MLN to map M to S. To differentiate between triangles, we label the translation of triangle MLN as triangle M', L', N'. Since the translation maps point M to point S equals point M'. Now, rotate triangle M', L', N' about point S to map segment M', N' to segment ST. Since rotation preserves length, the length of segment M', N' equals the length of segment ST. So point S equals point M', and point T equals point N'.
Don't worry, all they're doing is just proving what we're going to use for the rest of the year. You just have to know that you can use this information.
To prove that triangle MLN is congruent to triangle SRT, reflect triangle M', L', N' across line ST. Because angle measures are preserved with reflections, segment M', L', coincides with segment SR, and segment N', L', coincides with segment TR. The intersection of segment SR and segment TR is at both point R and point L'. Since the intersection of two segments is unique, point R and point L' coincide. Therefore, triangle MLN is congruent to triangle SRT.
Which is all we really care about, that if you have two angles and the side in between congruent to two sides and the angle in between, then you know the angles are congruent. Once again, trying to have you describe a series of transformations that maps it onto each other just to prove the theorem. I'd rather have you just apply some problems. Let's jump to it. You should be able to do problems 20 and 21. That's it for this video. Have a great day.